Hey everybody, welcome to our panel on hardware entrepreneurship. We're so excited to have you. We have some great guests and a fourth guest will be joining us shortly. So I'm going to jump right into it. I'm Ken Rother. I'm the director of hardware programs at Rev Ithaca Startup Works. So this is one of Cornell's incubators, where over the last 10 years we've been running programs to help hardware entrepreneurs go anywhere from ideation all the way through to manufacturing. And we have some great guests today, both from our ecosystem at Cornell and from the broader ecosystem. So I'd like to just start off and just jump into introductions. So I'm going to start with Lila Partridge.
Good afternoon. Thanks for having me. I'm excited to be here. Lila Partridge, and my background is pretty varied. I started life as a banker, funding a lot of manufacturing facilities that I've walked through, paper plants, mills, and things alike. And then I was at the early formative years at Intel Capital. So I did a lot of investing in hardware, raised Intel's only outside venture fund. There's an HBS case study around that. And then I got the bug and jumped down and did a bunch of startups. Most of them were in software, and ended up full circle back at Techstars running the Stanley Black & Decker accelerator focused on AI and manufacturing and electrification. So again, a lot of hardware involved, and I'm excited to be here and look forward to the conversation. Thanks for having me.
Awesome. Hunter?
Hi, I'm Hunter Adams. I'm a lecturer here in the Electrical and Computer Engineering Department. I teach two big classes in this department, one based on microcontrollers and another based on FPGAs. Both of these are hardware design classes that culminate with student projects, which is just to say that I spend most of my calendar week in the lab debugging hardware projects with students, working through issues, celebrating small victories, that kind of thing. I'm also a big recreational engineer, and so when I go home, I'm often doing hardware projects as well. I've been at Cornell for a while. I came here as an undergraduate in the physics department and then did my PhD here with Mason Peck in the aerospace engineering department. And now I'm in the electrical and computer engineering department.
Awesome. I am now going to refer to myself as a recreational engineer. I love it. Deanna.
I'm Deanna Kocher. I have a background in mechanical engineering, industrial design, and child development. I've been a little bit all over the map in my career so far. I started out actually in construction, doing high-rise buildings in New York City. So if you've seen like the Lantern, I worked on a building similar from the same architect there in New York City for a couple of years. Then I transitioned. I came back to grad school and was studying child-robot collaboration here at Cornell. And now I lead our hardware accelerators. So I've been working with startups from early idea conception up through small batch manufacturing, sometimes longer run manufacturing. So I've worked kind of across the board. And I also teach up in the engineering school. I'm a visiting lecturer in mechanical engineering. So I teach our introduction to mechanical design here at Cornell. I guess to add on to Hunter's point, I like differentiating between the capital E engineer, which is what my day job is, and that lowercase e engineer, which is all the stuff I do at home.
And I'm glad to see Ryan was able to join us. Ryan, you're on mute, by the way. Paradoxically, ironically, whatever the right word is, this is a hardware entrepreneurship panel. We had a slight hardware problem. Ryan, we're just doing intros. Who are you? What do you do? What's your relationship to hardware and entrepreneurship?
Yeah, well, finally I made it, and thank you for having me here. Really excited to be here. As always, more than a decade ago, I graduated from Cornell as a chemical engineer. When I graduated, the dean told me that I was going to be a highly paid plumber. And that's what I ended up doing, plumbing things that flow from gas, hydrogen, liquids to data, commerce, capital, and most recently electricity. So I started up a hardware startup called Revert Technologies, and we specialize in turning things off for businesses with IoT smart power adapters and cutting electricity flow to devices when they're not in use to save electricity. So that's what I'm up to nowadays.
Awesome. All right, well, I'm going to come right back to Ryan. So we met Ryan when he applied into our early stage accelerator program at Rev that Deanna and I run. But what I don't remember actually is like, where was the genesis of the idea? How did this even start? I don't even think about the pivot yet. I just want to know where the first idea came from. How'd you get there?
Well, it was really found by accident. Doing student research and student, led startups. This was, I was getting my MBA at the time at Yale University School of Management, and I met a couple of engineers there, and we were, Yale bought a bunch of electric lawnmowers, and we were trying to convert those lawnmowers into energy storage units to take the whole facility off the grid. That was how dumb and fun we were as students, right? Trying to explore different things. And one thing led to the next. We realized, hey, after the sun goes down, lights off in buildings, temperature, you can turn them off, and so they're no longer heating and cooling. But there's always a drain on battery, and what's that load that's always there? And that's that vending machine, that's those display TVs, computer labs, everything that's still working in there when nobody's around. And so that became the genesis of Revert Technologies as you see it today. But it all kind of started with a student-led idea, experiment, and fun, and one thing led to the next, I guess.
All right, thank you. And the questions I'm gonna ask everybody kind of follow the timeline maybe of hardware evolution, of a product evolution. So Lila, as the investor in the room now, I hope you don't mind that label. What's the right time? This is a question folks ask us all the time. Like when should they talk? When should they start talking to investors? Like when do you want to start that relationship?
So I'd say it depends. And what it depends on is the investor. And no two investors are the same, but very broadly speaking, they fall in a bunch of buckets. And the most important bucket to understand is what stage of investment do they want to actually invest in? And that will determine if they want to talk to you when you're kind of beginning your company, or are you at a point where you have lots of customers and sales and repeat customers and all the like. So it's really important to understand kind of stage. The second thing that I would note is that only 3% of venture capital goes to hardware. And that happens typically when you're already manufacturing and have customers. So if you're in this early stage, a lot of what you need to do is understand who is actually interested in potentially investing in you. And then, and I think Ryan, you and I can talk about this. I'm sure Deanna, you also teach this as well. In an accelerator, when you've kind of identified who you'd like to work with, engage early and begin to communicate regularly, right? Give them monthly updates about what you're doing, be very transparent about what works, what doesn't, what you've learned, and really begin to bring them along in that journey so that when you actually knock on the door and say, here, I'd like to ask you for money, they already know you. They already see how you've dealt with challenges, and it's really very personal. People invest in people that they feel comfortable with and in ideas that they can relate to. And the other thing that I would also note as the last point is that there's really 4 things you have to answer. What problem are you solving? Why are you uniquely positioned to solve that problem? And how are you solving that problem? And then lastly, why now? And that's a big one. People often miss the last one about why now. And that has to do with, is the market ready for your solution? And you really need to answer that question. So I'll pause there. I'm sure Deanna and Ryan can also jump in because you had that experience.
Yeah, I'll pause. I'll go to my next question, and anyone can go and build up on others. So I want to go back technical a little bit. And one conversation Hunter and Deanna and I have had a few times is sort of what differentiates hardware from software. So you spent a lot of time in the lab at school, lab at home. What are some of the surprises you see maybe on a regular basis or to see when people go from, paper CAD to circuits, soldering, wires, batteries?
Sure, I could talk about that a little bit. A lot of the folks with whom I'm building things pretty regularly, it's often the case that that I'm helping them through one of their first experiences with building something physical. And it's interesting. One of the interesting things that I've observed is so many of the folks that I encounter, they're very used to the technology with which they interact on a daily basis, just working. Most of the technology with which we interact, usually, it works so well that it's almost it's notable when it doesn't work. It's notably inconvenient when it doesn't work. And so it's really surprising for folks to discover just how hard it is to build something that works, particularly something hardware. And I think part of the reason for that is that when you're building something in physical reality, your debugging environment, sort of the domain in which things could go wrong, is pretty much as big as it could be because it includes all of physical reality. And so you're not just in conversation with your software, and the nature of the bugs that you may encounter aren't limited to the code that you write. The bugs may instead be involved in the circuits that you put together. Or even more subtly, and I think more fascinatingly and interestingly, it may be the case that you have perfect code and a perfect circuit, but the physical layout of the device that you've built is causing physical interactions that you haven't accounted for. Oh, I've got all this noise on my analog signal, and it's because you've put it too close to your high-speed digital signal or some such thing. Or, oh my gosh, where's all this 60 hertz noise coming from? And students are sort of amazed to learn that, oh, it's the wires in the wall that are generating these fields. And so you bump all the time into these consequences of interacting with reality in this way. It leads, I will say, to some really delightful surprises as well. One of them, I would say, is when people go through and successfully build something that works, I really think it fills you with a big humility. And as you move through the world and interact with the constructed world around you, I'm less inclined, and I think the folks that build things are a little bit less inclined to overlook this technology that's easy to overlook. My example is always keyboards. Like, I've had my computer for like 6 years, and I've been beating away at this thing for like 8 hours a day. The keyboard works great. It's miraculous. And so I think people are surprised to learn how challenging this is. I think people generally delight in the fact that it puts you in conversation with physics in a way that I think a lot of other things don't, in a way that problem sets kind of don't. You're not interrogating with it, you're in conversation with it in a really delightful way. And then once the thing works, it's a really cool feeling. There's a certain inarguability about a physical device that works. I've done a lot of work in the past with simulation, and there's good reasons to write simulation, but you can always poke holes in a simulation. And it feels really nice to build something and put it on the table and say it works and go, oh my God, there's no simulation involved. This is just, it's working in reality. So there's a bunch of surprises. And I think the surprises start in the frustrating category and then move almost towards like I don't want to be too dramatic, but towards like an enlightenment category. It changes your view of the constructed world around you and the natural world too, I think. But mostly the constructed world.
I'm going to layer onto that because that's the engineer's point of view, if that's okay, Ken.
Yeah, please.
And I love the way you describe it, Hunter, because there's really something incredibly rewarding as an entrepreneur to have a prototype, bring it to market. And one of the things to understand as you engage in investors or potential supporters, whether they're customers or not, is that they're going to want to make sure that you can not only build one, but you can build 10,000 or million identically. And so that's risk, right? If you just describe the process and the learning that has to happen to get to the one device, investors are saying, okay, that's one level of risk. Okay, and now the second level of risk is, can you make a lot of them identically? And with each risk, you want to reduce the risk for an investor to be interested. And it's really important to understand that some investors love risk and some want all of it to be eliminated. And that's going to be, again, this notion of who you're targeting for monies at various stages as you build that first prototype and then you get it into production and hopefully into a lot of customers' hands, right?
Yeah, sweet. Yeah, Hunter, remind me to tell you about my adventures with bus crosstalk one day. It was a long day. Deanna, so I'm going to say we, because we work on this together. You've seen tremendous amount of companies sort of start. We have our prototyping program. Sort of, can you contrast, like maybe even think about Ryan? Like, where do people think they need help versus where did we actually have to help them? Like where is it? They come in, like where what are they thinking and like what are you thinking?
Well, I will spare making Ryan a specific example because I had a generally wonderful experience working with Ryan. But I think this question is so interesting because it pulls off of what Lila just said and what Hunter just said, right? We had two very different perspectives of like kind of the investor hat versus the engineering hat. And like Lila, I love that you said there were four main questions. I don't remember exactly what they were, but the first two were all about who is the customer, who is the person, and then the third one was like, and how do you solve the problem? And I think when you look at Hunter's response here, talking about engineers, there's this really deep tendency to say, I'm gonna make a thing. And so I spend a lot of time in the early stages with people saying, I just need to open a can of engineers, or I am an engineer, I just need to crawl through the tech. And really what we spend a lot of time doing is saying, well, the tech, a lot of the tech might already exist. I can't tell you the number of times I've worked with people and said, well, Bluetooth is, we can add Bluetooth, but if the sensor doesn't work, then it doesn't matter that you're sending it to your phone because it's bad data. So we spend a lot of time trying to figure out, like, what is the customer? What does the customer need, to Lila's points? And then opening up the can of engineers and saying, and now let's get this thing built and let's troubleshoot as we go, all making sure that at the same time we're pulling that customer piece back in. And so I think that's where I spend a lot of time, and actually we did do this with Ryan when we had this really like cool technical feature, and we said, okay, so now Ryan, what does the customer actually need? And I do that with so many of our entrepreneurs that come in with an idea, either with tech or without tech, whether they're a technical or a non-technical founder, we get both. But it's always a matter of like, we have to make that tech line up with a person and a problem and a solution, and making sure that we haven't just over-engineered. It's 2025. We have really high capacity engineering abilities, and we need to make sure that we're not just over inventing the wheel when we can do something really simple and efficient. So I think that's usually what I see, is taking that engineer that's crawled into a pile of wires and pulling them back out and saying, what does a person need and how does it solve their problem?
So, Ryan, oh, go ahead, Ryan.
Actually, just I want to offer some perspective from an entrepreneur, an operator of a founder and operator of a business.
Please.
First, I'll expand the definition of what Lila mentioned as an investor. Sometimes it's not just money; it's advice of what not to do. Your investors may not be able to tell you what to do because that's what you got to figure out with your customer, but they'll tell you sometimes what not to do from their experience. And Lila has been my mentor from Techstars. Ken's my mentor, and Deanna's my mentor at Rev Hardware Startup. Think about that, right? Like it's not just capital. It could be intellectual. It could also just be sound advice, right? The second thing that I want to talk about really quickly is there's this, hard and difficulty and challenge of bringing a product to market, but there is the 10 times hard thing that you got to overcome, which is to build a business around the product you just built. And so as your company grows and scales, it's less important about how this product performs. It's engineered, is reliable. It's about how you service your customers, the terms and conditions, right? Case in point, if you go to Cornell's Helen Newman gym, you see a reverse product turning off the treadmill day in and day out. We've been doing that for Cornell. We can do it for 10 plugs, 40 plugs, and 2 gyms. But to roll it across campus, thousands of plugs, thousands of nodes and points. How do you manage that from an operational standpoint? Those becomes more and more challenging as you go, right? So I just want to kind of highlight those differences.
Yeah. Well, actually, I had a question for you. So when we met you, you were a B2C company. I'm one of the C's. I have your product. But and just about any of my participants or students who do a Kickstarter, I'm good for one. But you made a big change. I'd love to hear more about sort of the mindset. Like, where did that come from? Why'd you do that?
Yeah. No, to Ken's point, right? On this entrepreneurial journey, you're going to pivot a lot because you're going to learn a lot because you come with a preconceived notion of what this world ought to be. And then this world will tell you what it wants to be. And I think that's where, rubber meets the road, and that's where reality hits. We actually thought that, hey, we should be launching into the consumer's world with our product, right? We can manage energy for your homes, right? Turning off those phantom load, ghost loads on your TVs and stuff like that. And that's our initial angle. And that's why we ran the Kickstarter campaign to garner all the pre-orders from folks. Talk about timing. We launched at, the end of 2022 where, energy costs were starting to go up because of the, supply chain disruptions, war, going on in Europe and so on and so forth. And so it was a really good timing. And we had people who wanted it. But ultimately, why we decided to go for businesses, right? You got to think about a product like ours. We need scale. We need volume of orders, right? And that consistency comes from businesses, not from doing Facebook ads to get the next customer, but actually getting a large procurement order from a large university like Cornell to say, hey, I want 4,000, 5,000 of your devices rolled in the next 3 years. That predictability allows you to manage an operations better. And practically speaking, right, when they're pitching consumers, you already know the answer. They're like, hey, how is this different from an Amazon smart plug I can buy on an Amazon? And when you pitch a business, nobody asks you that question. They're like, well, we don't have Amazon. We don't even have Alexa running around our corporate. Cybersecurity concerns, usage cases from a business very different from consumer. You quickly realize, oh, here's actually a wide open lane, right? Versus, oh, there might be some preconceived notion in the market. And so naturally, you start to focus on where the solutions start to make sense and where you can build moat around your business.
Cool. All right. I'm sorry. There's a question. I'll get to it in a second. So Deanna, building on what we just heard, we see people literally with a napkin. They build a prototype, and now they're thinking they need volume. What are some of the misconceptions? You don't just photocopy this piece of electronics. Like, what are some of the misconceptions of going from volume, going from one to many, as Lila talked about earlier?
Yeah, I think that's probably the biggest like gray area, and not just for startups. It's also probably the grayest area for people who are young engineers going out in the field or taking their first jobs. This is kind of that area where you don't get a lot of practice with this in school. You don't get a ton of experience with this until you go out and you have a product like Ryan's, where okay, now I've got to put 10,000 in a single batch. I've got to optimize on the assembly time. I've got to make sure to have quality inspection. And what a lot of people don't realize is that getting from that one to five is okay. 5 to 10 is probably okay. But once you start talking outside of your garage, outside of hand building, hundreds of thousands to tens of thousands to hundreds of thousands, it's almost an entirely different product. And the process that you have to go through to go from that the first one that you've built, usually is going to look entirely different than something that is manufacturable, that's easy to assemble, and is going to be efficient. To Ryan's point of, I could make 100 gizmos, but if I want to make a product and if I want to make a business, that needs to be efficient and cost effective. The supply chain needs to be secure. And that's what we see a lot, is that you basically have to redo. And if you start the process with a team of engineers, you might be a little bit better off if that team of engineers has experience. But when you start all with engineers, you also limit the way you're thinking about a problem, and making sure that people are casting the net wide open when they start, but then being able to recognize you've got to narrow the funnel and then get to something scalable that a manufacturer is going to look at and take seriously and is actually able to be produced with the quality where it can be identical enough that it can be made hundreds of thousands of times. That's usually the biggest thing, is that you get tied to this idea, you think it's great because it's working, and you don't see that there's actually this big chasm between the first 10 and then the first 1,000. And that's what we spend a lot of time working with people and going through the DFM, design for manufacturing process, to actually make something that is now ready to scale and be pushed out at volume.
I want to pick up on a couple of things both Deanna and Ryan said. Spot on entirely. And now I'm going to kind of sort of view it from the investor perspective. And one of them is going back to what Deanna said about customers. And I think Ryan also mentioned it. You want to engage your customer early. So let's just say you have a prototype. Don't just kind of like go from 1 to 10,000. Really go and talk to customers, because it may turn out some of the features you have you don't need. And by the way, you can then pull them out of the manufacturing process, get a simpler, easier device to build. And on top of that, you may also have the wrong features. And so you really want to go and make sure that before you do the scaling, you are absolutely certain that you've got the right product. And this is the issue that I think a lot of investors wait for, because they want to see customer traction, because then they know you're building the right thing. And so one area that I wanted to touch on that Brian mentioned is, customers are important, but sometimes corporations, particularly in B2B space, are more important, not just as a customer, but if you're able to tap into them for their knowledge, because they are actually in the marketplace with the supply chain. They're actually in the marketplace with customers. They see what's being used, what's being bought, what's not being bought. They really know the market better than anyone else. And so sometimes engaging early with, say, a corporate and potentially a corporate investor, you're doing it because you want market information. And that market information will help you make sure you intersect with the right product. And you don't build 10,000 of them only to find out, oh, I wish I'd built something a little bit different.
And I love that point because I think especially at that low volume, that 1 to 1,000 type jump, everybody thinks, oh, well, if I just want to add Bluetooth, I'm just going to add Bluetooth onto my one device. If any of Hunter's students were told, oh, we need Bluetooth, they can add a Bluetooth chip, they can get it connected, no problem. But then when you tell an entrepreneur, you tell a founder, okay, so that Bluetooth that you've decided to add on is going to cost you $30,000 to certify, then they step back and say, wait a second, what? So I think that's such a great point of making sure before you make that jump, you've got the right thing with the right features because those features cost a lot more when there's 10,000 of them.
And to your point right now, what is the actual cost of the product you're building? You may want this great product with 10 different features, but the reality is your customer only really needs 2 of them. And the cost could be prohibitive if you build them with all the great features. So be really focused and really engage with customers to figure out what it is that you can afford to build and sell at the right price point.
This goes to one of the questions that was asked. So the question is really looking forward to hearing more about validating customer interest. I'm struggling with this aspect. I know all 4 of you have an opinion on this because I know all 4 of you work this problem. So I'm gonna get to all of you in a second. I'm gonna take the power of the gavel and give my answer. And you know, my answer is always going back to something Lila said. Before I'm worrying about what I'm making, I'm worrying about what problem I'm solving. What is the customer trying to accomplish? Or as in the words of the late Craig Christensen, like, what's the job to be done? What are they trying to accomplish? Then your job is to help them accomplish it. So I'm going to go to you, Hunter. You're the engineer in the room, but I work with you in iCore. So I'd love to hear your thoughts about validating customer interest.
Sure. Perhaps I could speak a little bit to some personal experience.
Yeah.
So the iCore experience with which I worked with Ken that he just alluded to is one where I was trying to commercialize some technology that I'd worked through in grad school, and I'd made little satellites for deploying in space. And with Ken's help and the other folks at Rev, I was trying to commercialize them as digital agriculture tools. So instead of putting them in space, put them in orchards and vineyards. And essentially, the thought was perhaps we can replace a single weather station that approximates the environmental conditions across some, bumpy vineyard with little microclimates with instead 100 little weather stations. And those weather stations can be right next to the fruits underneath the leaves where they trap the cool, humid air. And perhaps that informs maintenance schedules in a way that is, economically meaningful for the vineyard manager. And I would say one of the most challenging but then most useful things to learn about that particular customer segment, and I wonder if this extrapolates to others, perhaps others in the room can tell me, is to figure out the units in which their brains operated. And so, for instance, I learned that the units in which these vineyard managers' brains operated appeared to be dollars per acre. And so if I could talk about the value of my product in units of dollars per acre and the cost in units of dollars per acre, that was the shared language that I needed to have with this customer segment, where I from my world and they from their world, we could agree on this interface of units. And it took a while to figure out that unit. Perhaps it's something that's obvious in retrospect, but it certainly wasn't obvious to me at the time. I don't know if others have had similar experience with trying to identify the appropriate sort of units with which to discuss a technology.
Ryan, how'd you validate?
Well, this is a story of many painful lessons learned, continued customer discovery. And you know what? I'll just use Cornell University as the best example because I think everybody here can relate. We save energy for Cornell. It's a pretty straightforward operating expense reduction on utilities spend, but also it's an environmental story and sustainability and making the campus ultimately lower in carbon emissions and carbon footprint, right? So pretty straightforward application of turning off a gym full of equipment, overnight and nobody uses, and so on and so forth, and translate that into savings. However, right, this is this classic example of what not to do. We thought the customer would want a beautiful dashboard to tell them how every single plug performs and when are we in use and when are we not in use. Let's go show them the machine learning capabilities behind it. You know what the customer wants? Set and forget. I just want to know this thing is saving me energy, and I want to know how much it's saving me. And if it's ever in my way, if there's a student who wants to use the Toni Morrison gym once in a while, how do I wake up that machine, that particular treadmill, That's all they want to know. So guess what Revert is now doing, right? We're reducing our pull on the dashboard. It's beautiful. It doesn't make any sense to the customer. We're actually inventing how to report and bill Cornell. Like every month, we show them the monthly impact report. This is how much energy we saved you. This is why we saved you this much energy, right? And then the other question is, how do I believe in your measurements? So guess what? It's not, about how to turn things off and on with AI. It's actually about how do I get my measurements certified to be certain percent accuracy in the power readings, so people will pay you on the savings that result that you can self-report. So big lessons learned, right? You think what is a good product actually is not what the customers need. And we actually devoted lots of resources to do something that was probably a little bit overkill. And so even we are still learning how to service our customers into Lila's point and Ken's point in just what they want, right? And because you're resource constrained, you're so resource constrained in the beginning, you can't afford to do it all.
And I would just reinforce both what Ryan and Hunter said, which is, the example is great, Hunter, which is you need to talk about it in their language. You need to understand how they measure their own ROI. To Ryan's point, you need to really understand whether they want a given feature or not. And the only way to do that, and this is where I'm going to give you a formula, the only way to do that is to talk to a lot of them. Because you could find one customer who's going to spend a lot of time talking to you, but they don't actually represent a market that's sizable enough to support your product. And so when we were running accelerators, and I think Deanna, you probably can comment on this as well, we forced our founders to go out and talk to customers. And nobody likes to knock on a door kind of as a cold call and ask questions. So we're, as human beings, unlikely to want to do it. So we forced them week by week by week. And the idea really is you should be talking to 50 to 80 customers before you make decisions. Because if you only talk to one or two, your probability of understanding the market fully, be it a vocabulary issue like Hunter talked about, be it, a feature issue like Ryan talked about, or even being it whether this is something people want. Maybe you need to switch a little bit and move a little bit to the left to get the market size you need. That only comes from talking to a lot of people. So 50 to 80, and then you'll get a better sense of kind of, is there a market for what you're trying to build?
And 50 to 80 of the right people.
Right.
That's what we spend a lot of time, especially in the early stages of our program. I have a number of entrepreneurs that have come into our first program right now that they have an existing prototype, and they've been walking around and showing it off, and that's all well and good, but then you're going to get different feedback and you're going to get ideas for different people, and a different customer is going to want something different. And so if you take an event planner versus a downtown bar, I have a company right now that's working on something for bars, and it's like if you talk to 8 different people that are in 8 different markets, that's not 80 people, that's 8 people, right? So making sure you're talking to the right people, you're getting that feedback that's not, oh, you've built something cool, but like when can I get it? Or I've been actively looking for a solution to this problem, without you telling them that you have a solution to their problem. But they're out looking, they have money to spend on it, and they're interested, they want to stay in touch with you. You're really looking for all those green lights to make sure you've got the right person and the right product.
And don't forget to ask, how much would you pay for this? Because, people love to say, oh, this is wonderful. This is great. I'm so glad you're doing something. But then you say, well, how much would you pay for this, right? And because that's going to be your ability to figure out, can I actually build it for that cost, right?
I'll point out to the folks that are listening, not one person used the word survey. They're saying talk.
Oh, yeah.
Surveys are not talking to, so just a lesson. Going way back to one of the earlier questions, this is kind of a much more qualitative question. Well, I'll start with you, Deanna, and anyone can jump in. Which part is more difficult in your experience? The prototyping part, and I'm going to add to prototyping, figuring out what to make, or the getting it into production, producing it in volume part? Like how, and that's a very unfair question, but I didn't make it up. Someone else did.
I mean, I think it really depends where you're coming from. And like to everything we've just said about figuring out what to make is hard in the sense that you need to figure out who wants it and what problem does it solve, and have you solved the right problem. And I think that part is really hard. If you're talking about, what the problem is and you have a way to solve it, I call this the hack and slash, like garage build region of prototyping, where we can take stuff off the market. We need to prove feasibility, right? We're going to take stuff, we're going to rip it apart, we're going to scrap it back together until we've come up with something that achieves this thing we wanted to achieve. And so I think that part of the process, there's lots of engineers that love to hack and slash and just be slapping things together until you get something that works. To Hunter's earlier point of all the surprises that you find and all the things that come up, and you have this like, great, I've built one and I put it on the table. You know, that's that might have a handful of challenges in it. I think the big problem on the front end is usually making sure you've built the right thing. When you transition over and you're talking to high volume, now you've got problems of scale, quality, testing and assurance, all of these more longer term, larger scale problems. And if you had a bug in that system that you then send out 10,000 parts, or you think about cars and recalls, if you are if you are Ryan and you're a, small startup, small company, and you send out 10,000 products and suddenly you've got to bring all 10,000 of them back because you realized that you had the wrong firmware and you didn't have a way to reprogram it or something like that. Now you've got headaches, 10,000 headaches, as opposed to when you built that first one and you hacked and slashed it. So I guess it's not that one is easier or harder than the other, but they're just very different skill sets. So I guess that would be kind of my starting point answer to that.
Can I offer some thoughts?
We're all probably all thinking of a juice company right now, but go ahead.
I was just going to offer some thoughts on this as well. And maybe this is just my personality, but I think I get a sense of meaning from a sense of making progress. And to me, the prototyping phase is easy because I get a real sense of meaning from it because something's coming together before my eyes. I can see the progress right in front of me. And when you get to these later stages where the progress is a little less tangible, for me personally, my sense of meaning and the feeling that I am actually making progress in a substantial fashion starts to go away, which makes it harder for me psychologically. The prototyping phase psychologically is, I don't even know if I would classify it as hard. It's not without its challenges, but it's so full of like the sense of excitement and meaning, and it's so cool to watch something come together. And when it changes, when what progress means changes to these other things, I struggle with it.
I want to make an observation because as an investor, you look at risk. You look at actual people who are able to reduce risk. And Hunter, you're clearly an inventor. You like to invent that prototype. And that's the stage that you're just your sweet spot. You can hear the excitement in your voice. Deanna, you're talking about scaling. And, you've kind of, an implication, there's a lot of expertise of people who've just done, maybe getting rid of that noise and that, crosstalk in an FPGA or whatever. And those experts, there's like maybe one expert like that at an Intel or an NVIDIA. And you're full of companies that have people with very specific expertise around that scaling. And I view them as being very different skill sets and very different ways of reducing risk in a startup. So there's the invention stage, which I think the people who are founders tend to be inventors. Then there is the scaling stage, which has its parallel also in business. There are business people who love the early stage and then walk away when you're building the business larger. And then there are people who come in and say, I'm a builder. I want to build what's already there, but I can't invent. And so I think a lot of times it has to do with getting the right expertise at the right time, which means often very different type of personalities. And I think that's very well understood by investors because they will look for that, again, stage. I'm a stage investor that loves that invention stage. I'm an investor who loves the scaling stage. And their LinkedIn contacts and their expertise tends to reside in those stages.
And there's the exact same thing, just to chime in real quick, and then Ryan's all yours, but exact same thing with engineers. There's engineers that love hack and slash. There's engineers that love quality control and fine tuning and statistical process control and looking at the details of those 10,000. It's the exact same thing in the engineering side.
I'll chime in here once again from the perspective of a founder, entrepreneur, operator of a business in that stage of going from, we went from 0 to 1 to now 1 to 5,000 at a time. And so here's what I learned, right? Number one, the 0 to 1 phase has a very unique challenge for hardware. Measure twice, you got to cut once because you don't have enough capital to pivot and reshape your mold or whatever, your electrical circuit board. It's not like software. You can just reinvent the whole wheel if you wanted to overnight, if you're that good at programming. So hardware, you can't. And so you best be sure what you're building is the right thing by talking to so many people. And to Lila and Ken's point, right? Talk to them and get that common desire, common demand, and common theme, and built for the common denominator. That's that challenge of the 0 to 1 for our hardware in that beginning. And then I will tie into Hunter's point because I'm here right now. And so much of that early progress is controllable by you and a very small team, right? You and your co-founder, you can control that. The problem is at the later stage of this scale up phase, you have to work with many, many people involved, manufacturers, people, general labor on the line who is not as skilled and trained as you are in the arts of mechanical engineering and so on and so forth. That progress is not only hard to measure, it's also dependent on other people. So your skill set as a leader of a company becomes, how do I motivate a team of people whom I probably never met, probably all over the world, to build the thing I need, and then somehow conjure everything together into the product you want, your customers want, in a good enough quality and consistency across the board. That becomes much more challenging, and that's the stage that I find myself in now. Oh my God, it's not just, me and my co-founder going at it, at night, and we can pivot all over, but it's like, oh my God, I can't turn the ship around if we're committed to buying this many chips, this particular chip, this particular form factor. That's just something that I want
Can
to
I ask a question about that? Because
Yeah.
I've never gone through this process myself, but I can speculate about something I might feel about it. Maybe you can confirm or deny. It seems to me like it would be I don't know, an emotional process to also go from a group of people that all share a love for what you're doing to having to incorporate and rely upon people who don't love your product like you do and don't share your vision in the way that you do, but upon whom you rely just as much as those who do. Is that challenging?
Absolutely. This is the stage that you're describing, because as your circle, right, as your team grows, right, everybody's motivation is very, very different, right? Even Revert as a small team, right? Initially, you're all just mission-driven engineers, right? Myself included. I sort of have an engineer now that I got a business degree, but you're mission-driven people who wants to do something right for the world, and you're kind of, into that. Now then you have investors coming in, right? Now then you have suppliers coming in who are not, necessarily motivated on your core mission, but they're looking for a return, or they're looking for a business to be built around what your idea is, right? And as your circle of influence starts to grow, it becomes more and more somewhat transactional in that sense, and less so of a relational, right? Of that sense, right? So that is an emotional transition you have to undergo as you, manage a larger and ever larger team. And that, to many, the point that's made earlier, sometimes you might not be the best person to do that, even, right? You got to find help, right? We have a CTO in our business. I'm the CEO, but what we're lacking right now is good COO, Chief Operating Officer at this stage, who is sort of less emotionally attached, can lead transactional relationships at that scale that we needed, across multiple, engineers and so on and so forth. But over time, as people have seen success, they'll come and join you. They'll have, each different motivations to hop on your ride, but at this, but you're all driving towards the goal that you're ultimately after. And that to me is still ultimately the most satisfying part about this whole journey. It's like, hey, we're still making the impact we're making. You might have a different, take off of it, but that's okay.
I want to kind of add another topic here,
Yeah.
Ken, which is a kind of
Please
piece
do.
of what Hunter and what Ryan said. So really, when I think about early stage companies, it is really a lot of fun. Tight teams, all motivated the same way, wearing a lot of different hats, doing a lot of really cool different things, and then you get very distributed and larger. And so when you think about what is a large company compared to a small company, and then how do you bridge perhaps working with a large company who could be really critical to your success? And that goes to this notion that large companies have lots of expertise, lots of market presence. They may be global reach as well. And so the challenge in running a large company, to Ryan's point, is about coordination. So a lot of times people talk about the frustration of talking and working with large companies because it takes forever. You have to talk to 5 people, you get them all on board. They may change jobs in the process. And so the key is that in large company, the company is focused on coordination. Now, if you effectively coordinate, then overnight, a large company can build up a big factory, they can open up a new market, they can do tremendously high impact kind of things that a small startup, which is constrained on people, money, time, and everything else, cannot. And so this notion of coordination and collaboration is critical as a small company may want to work with a large company. I know, Ryan, you've had a lot of experience with that, but that can really become a critical jumping off point for a small company to really be successful. And so the difference between those two types of companies, Hunter, is spot on and absolutely critical in understanding.
Yeah, I love this observation. Ryan, I want to I think it's related. It's a very practical question. You're in market. Um, can you talk a little bit to sort of complexity of supply chain these days?
Okay, am I allowed to mention the word tariff in this conversation?
They exist. They exist. I mean,
Yeah, they exist, and that's what goes to the increasing complexity of building hardware product. You have the dimensions of product market fit, those type of things, to shape, the mold, the mechanical performance, reliability, and supply chain. But now you have politics involved, right? Like the rules have changed in terms of overseas supplies with tariffs and situations like that. It's a very real risk to a business, both to your unit economics of, hey, what's your ultimate value to the customer they're willing to pay? But then your cost has just escalated because now you have a tariff on either the component or the full finished goods, right? If you do it all overseas. And so that increases a level of risk to your business. In addition to that, we're in the business of making 5,000 units, right? And, with an increased tariff, right? Like, it used to cost us, let's just say $100,000. Now it's like $300,000. Nobody budgets for that, right? In your startup. So we didn't raise money to cover tariffs, right? So that can be a very huge risk on your balance sheet. So these dimensions, right, of supply chain are starting to come in. But you know what? At the end of the day, we're all engineers, right? Just like a product can be engineers, so can tariffs. The word tariff engineering, or the phrase tariff engineering, can be very real. Sky's not falling, world's not collapsing. You just got to look through some of the codes that are set in place and figure out, hey, how I can re-engineer this product, tweak it just a little bit, right, to kind of make it observe maybe a different tariff code and coming in, so on and so forth. And then broadly speaking, you got to think about your supply chain strategy. For right now, as a business, we're just laser focused on the consumer and the market demand. We have not yet the resources to completely change our supply chain and reshape it, unfortunately. So we had to deal with what we had to deal with, control what you can control, which is the customer side of things, and trying to ensure that there is continued demand for your product, and put some smarts and cleverness in tariff engineering, like changing simple designs of your product to kind of make it fit into a different category. So, one thing I'll say here about Reverse product, you can construe it as a smart electrical switch with a chip control logic. That's 180% tariffs. You can construe it as a central processing unit with an input and output. That's a computer, tariff exempt. So, that's the way that you got to go about it nowadays to survive as a business. But ultimately, as a hardware entrepreneur, run it lean. No matter what it is, it's always going to, you're always going to try to come out on top. And it's just unfortunate, but you got to kind of devote some of the engineering time to figure out how to reshape the supply chain a little bit, as much as you could.
Love it. Thank you. I'm gonna sort of start wrapping some questions. Deanna, what do we do at Rev? Can you quick? What's
What don't we do at Rev? So we at least in my capacity, we run 3 different hardware accelerators for Cornellians and non-Cornellians alike. And one of the things that I really like about the way we do it is we divide it right up into the stages the way we've talked about it in this session. We have a prototyping accelerator. That's the one we're running right now. That's the hack and slash. Who's my customer? How can I build it? What can I build? And what's going to be feasible for a product and a business, as opposed to this was a cool hobby. It was great that I built it. I can't sell it, right? So that's our first program, is looking at prototyping. And then our second accelerator that we have is protofactoring. It's exactly what it sounds like. It's prototyping, manufacturing, kind of smashed together into protofactoring. We call it this kind of gray area, that messy middle zone of I built one, how am I going to get this to be something manufacturable? And right now, that's kind of my sweet spot is we took the hack and slash and we have to figure out like, how do we transition it to something that a manufacturer is going to look at and they're going to take me seriously? And that's, I think, one of the big distinctions that we think of when we think of big company versus small company. Big companies have people that will look at them, take them seriously. They have the expertise. As a small company, it's your job to make sure that you can be taken seriously because you are not pulling in, to Lila's point, all of this huge pile of people and resources and expertise. And it's your job to make sure now you've cleaned up your product, you've done all the documentation to get it ready to go to scale and to have those conversations with manufacturers wherever they are in the world. And then our last accelerator that we have is manufacturing. And so that, in the way we think about it, it's kind of your first production run, generally speaking, your first 100, your first 1,000, whatever that initial volume is that makes sense for your product. And that is a year-long program. It's really tailored towards connecting with manufacturers, going through that process, vetting the new product. Like I said, it's usually something that's new at this point because it's gone through a redesign to be manufacturable. And so that's our last stage. And in all of our accelerators, we focus on both the technical and the business side. We offer engineering input. So I work with a handful of different startup companies right now, helping them get through kind of that gray area and get to their first batch of manufacturing. So those are the three programs. There's a handful of different moving parts around that, but that's kind of the high level overview.
Hunter, I want to jump to you for a second. So what Hunter didn't mention, and it's Hunter took over the courses that were run by this legendary fella, Bruce Lands, and his student projects showed up every year in a magazine called Circuit Seller that recreational engineers like me would read. I just, when you think about even your last cohort, are there a couple projects that kind of jump out as like novel, either in their approach of use of technology or their understanding of the world, or like, yeah.
Yeah, certainly. Maybe I can speak a little bit about the class to provide a little bit of context. So it's, as I mentioned, it's a project class. The class, I would say, I wouldn't classify it as an entrepreneurial class. Some students choose to use it as such, to do engineering as a mechanism of solving a problem. But the class is much more a celebration of creation. And so we get projects that are devoted to trying to solve problems. We also get a whole category of projects in which the students use engineering as the mechanism by which they learn about something else that they're interested in. The analogy I often draw is reading. You know, we're all interested in a lot of stuff. For many of us, reading is one of the items on that list that we like to do. But we use reading as the mechanism by which we learn about the other stuff on that list, right? If you like reading and you like history, well, perhaps you read books about history. And in the process, you're getting better at reading. But the point of it really is to explore this other thing on your list. And I like to treat engineering the same way. And so we get students that do generate projects that they end up sort of patenting and trying to commercialize, and that's a delight. And then we also get students that use it as a way to explore an interest in, for instance, I had some students that were really interested in the folks at Bletchley Park, right? And so they built some Enigma machines to try to better get a more intimate understanding of what Alan Turing was thinking about, right? And that's a neat thing to do. I have some students that were really interested in birds, and so they built birdsong synthesizers. Are you going to sell a birdsong synth? I don't know. I would buy one, but I don't know if other people would buy one. But that isn't the point. The point is that if you're interested in learning about this thing, well, this is a really interesting vehicle. You get a different look at this other thing on your list than you do by these other media. So I would say the most interesting thing about the projects is their variety. And they're all, I'll mention too, they're all published online. The students' final deliverables are web pages, and so we have just hundreds of web pages of student projects. All their code is posted, so you can go use it to do your own project should you choose to. There's lots of video games, lots of robots, lots of sensory augmentation projects, students that are very frustrated that they can't sense magnetic north, which is annoying when you think about it. And so they build devices to augment themselves to give them that sense in various clever ways. Projects that send information into your brain via a different sensory input than you're used to. So information that you're used to looking at, figure out a way to listen to it. And that reveals some interesting patterns sometimes about whatever it is that you're observing. People do this with DNA, for instance. You can listen to the sequence instead of look at it. We get a bunch of wearable projects that people like to sort of walk around, a bunch of artistic projects, the only point being that it's interesting to look at, a much more challenging thing to attempt than it might seem. I always caution students if they pose that propose to do something artistic, I say just, keep in mind that that's hard. Bunch of IoT flavored stuff, and so it's a delight. I would say, to answer your question, some ones that just stick out in my mind, not necessarily because they were the best in any way, but just because here in the moment they're jumping out. I had one group do a really nice audio localization project. So 3 little microphones on a breadboard, and you speak, and by correlating the inputs among the 3 microphones, they could figure out to a exquisite precision where the audio must be coming from. So they can point and arrow to exactly who's speaking. Had another group of students build what they called a Sisyphus machine. It's a coffee table with a robotic armature underneath it that moves a magnet, and there's sand on the coffee table, and so it moves a ball around and draws these beautiful mandala patterns and interesting mathematical structures. Some beautiful video games. I had the most lovingly accurate recreation of Super Mario Brothers I've ever seen, which is so much harder than you might think. It's really, really hard. Had a really nice Legend of Zelda emulation as well. Some sensory augmentation. I did have one group give themselves magnetic north, and it works. It's really interesting. They wore this device for about a day, and then they forgot they were wearing it. They just knew where north was. So it's a delight. And if you're interested in this kind of flavor of engineering, do please check out the student projects. They're so cool.
What's the URL?
It is. I can share it someplace if that's helpful, but it's ece4760.github.io. If you Google Cornell microcontrollers class, I'll bet you can find it in a minute or so.
We're almost at time. I'm going to give each of you like 10 seconds, something about hardware entrepreneurship. Ryan.
Something hard about entrepreneurship?
No, something about hardware entrepreneurship.
Oh, something about hardware entrepreneurship.
Yeah.
Well, it's hard. That's what I meant. It's hard, but it's fun. It's fun if you do it with the right people, the right team, and just keep at it if that's what you're passionate about. Because sometimes to make an impact, you're going to need it. Software alone can't do it, so it's worth it for me.
Lila?
We live in a physical world. We touch a physical world. We interact in a physical world. So software can't do it all. You got to build shit, and it's fun.
Hunter?
It puts you in conversation with physical reality, and I think that's good for people. And so I think it's a good practice to be in, to try to get things to work in reality.
Deanna? You're on mute.
No, it's easy to forget about the software. You can have apps on your phone can die. The physical things, they aren't going anywhere. We got to find a place for them, and we got to find the right problems to solve.
Love it. Thank you all so much for your time. It's really a pleasure. I so enjoy these opportunities to pull these kind of groups together. Thank you all for joining us today. I believe this is going to be posted at the eCornell website in perpetuity. So if there's something you really want to go back and listen to, or you want to share with someone else who you think would enjoy this, that's great. We do this on a sort of regular basis, not too often. eCornell does a whole bunch of these on all sorts of different topics. When you check out their website, you'll see all sorts of stuff that they cover. We might do some more on hardware down the road in the not too distant future. But thank you all again for spending time with us. Thank you to the panelists. It's just such a pleasure to chat with you all. And we'll see you soon.
Thank you.